Friend, in this video lecture, we are going to start the solution of linear equation. Solution of linear equation. First, Jacobian iteration method. Jacobian iterative method, and second, Gauss-Seidel method. First, we see the example of Jacobian iterative method. Solve the system 6x plus y plus z is equal to 20, x plus 4y minus z is equal to 6, x minus y plus 5z is equal to 7. By using iterative Jacobi iterative and Gauss-Seidel method. Solution. The given system of equation is 6x plus y plus z is equal to 20, x plus 4y minus z is equal to 6, x minus y plus 5z is equal to 7. 1, 2 and 3. Then first we use the Jacobi method. In this method, the given system of equation is written as the given system of equation is written as from equation 1, 6x is equal to 20 minus y minus z, then x is equal to 20 by 6 minus y by 6 minus z by 6, that is equal to x is equal to 3.3333 minus 0.1667 y minus 0.1667 z, that is equation number 4. Then from equation 2, y is equal to 1.5 minus 0.25x plus 0.25 z, that is equation number 5. And from equation 3, z is equal to 1.4 minus 0.2x plus 0.2y, that is equation number 6. In the matrix form, the given equation is written as The given equation may be written as in the form of x is equal to c plus b into x, where x is equal to x, y, z, and c is equal to constant, that is 3.3333, 1.5 and 1.4, and b is equal to the system of equation 4, 5, 6 and coefficient of x, y and z. In equation 4, the coefficient of x is 0, therefore 0, y is minus 0.1667 and z is minus 0.1667. In equation 5, a coefficient of x is minus 0.25, y is 0 and z is equal to 0.25. In equation 6, x is minus 0.2, y is 0.2 and z is equal to 0. This is B. Assuming x of 0 is equal to 3.3333, 1.5, 1.4, and x of 1 is equal to c plus b x of 0, and that is c is equal to 3.3333, 1.5, 1.4 plus b is equal to 0 minus 0.1667 minus 0.1667 minus 0.25, 0, 0.25 minus 0.2, 0.20, and again c. Again x of 0 is 3.3333, 1.5, 1.4. Then we get, after calculating this matrix, then we get 2.8499, 1.0167 and 1.0333. Then again use equation x of 2 is equal to c plus b into x of 1. Again put this matrix 3.3333, 1.5, 1.4 plus c is equal to 0 minus 0.1667, 0.1667 minus 0.25, 0.25 minus 0.2, 0.20, and again x of 1 is equal to 2.8499, 1.0167 and 1.0333. After calculating, we get the matrix 2.9916, 1.0458 and 1.0333. Proceeding in same way, we obtained x of 9 is equal to 2.9995, 1.0005 1.0004. Means same procedure use for up to the x of 9, and we get this x of 9 matrix, and we therefore conclude that x is equal to 3 1 1. Means x is equal to 3, y is equal to 1, and z is equal to 1, and which is required solution of system of Jacobi method. This procedure is used up to the term x and then get the solution. Then second method is Gauss-Seidel method. In Gauss-Seidel method, write the complete solution of Jacobian method up to the xn. Means first xn, that is xn x of 1 is equal to 2.84999 1.0167 and 1.0333, and with this values of equation 4 becomes x of 2 is equal to 3.3333 minus 0.1667 into 1.0167 minus 0.1667 into 1.0333. After calculating, we get 2.9916. Then y of 2 from equation 4, that is 1.5 minus 0.25 into 2.9916 plus 0.25 into 1.0333. After calculating, we get y of 2 is 1.004 and z of 2 is 1.4 minus 0.2 into 2.9916 plus 0.2 into 1.0140. Then we get value 1.0038. Similarly, in this way, we find the value of x of 2, x of 3, x of 4, x of 5, and all these stage we conclude the solution. Then similarly, we find the value of x of 3. X of 3 is equal to 2.9975. Y of 3 is equal to 1.0016, and Z of 3 is equal to 1.0008. Then x of 4 2.9995. Y of 4 is 1.0003, and Z of 4 is 1.0002. Then x of 5 is equal to 2.9998. y of 5 is equal to 1.0001 and z of 5 is equal to 1.0001. At this stage, we can conclude that x is equal to 3, y is equal to 1 and z is equal to 1, and which is required solution of given equation. Same problem is solved two method, first Jacobian iteration method and second Gauss-Seidel method. In this two method, first find the value of x, y, z from system of equation. Then by using these two method and solve the problem. Thank you.